Hi there. So today we're having a little bit of fun with GameGuru MAX and more specifically the visual logic. Now you see in front of me a wall with 5 lights and 4 switches, and they're connected using visual logic. Now normally when you using visual logic, you connect like a switch to a light and it does something. Now in this case, I had to flip 3 switches, and then the green light turned on, and the colored ones are pulsing in sequence. Now if I turn the 4th one on, the green light turns off, and the colored ones continue going. Now, so all 4 of these switches are turned on right now. Let's turn this one off, and the green light comes back on. And if we turn this one off, the green light comes back on. So how this is wired is that if any 3 of these switches is on, then the green light's on, and it activates the top lights. They keep going even after the green light gets turned off. So it's multiple events being triggered. And then this one, we have, I guess I forgot, there's 5 switches. This one makes the whole thing stop. Now, even after I turned it back on, the sequence is still stopped. Now, all of these are on, so we'll turn one off and it'll start back up again. Now this switch here will lock top lights all on too. That is until they all get turned off. This was mostly just my reset. So how does it all work? Visual logic isn't capable of doing that. So we'll go ahead and take a look at it. Now, turn on the logic connections here just so you can see it's a little complex. It is all wired using visual logic, and it's real digital logic. It took a bit of work to lay this out. I'm going to explain a little bit how it works. So we have a switch, and you'll notice the switch is connected here. This is an input. It will receive data from any object that generates a visual logic signal. It also has a couple other uses. But yeah, that's an input. Then we have a function. This one is an inverter, also known as a NOT. And then this one is an output. So every function has to have an input and an output. So you notice that there's 4 here, and each one is paired. Now, these inputs, though, each one has 4 connections because they also go into this AND network, where basically what this is each AND is connected to 3 switches and the output of an inverted switch signal. So it'll say if 3 switches are on and 1 is off, then we have a connection here to this output that goes to here, and this is an OR. So it says if this one is true, or that one is true, or that one is true, or that one is true, then we have our output here, and this goes two different directions. And this one here is what remembers the state of when you turn on the light the first time. The signal coming from here to there will be a logic high. And this OR gate here loops back on itself. This AND switch here is being used for the reset. For just a simple feedback loop, you would have the output here tied directly to an input that goes back into it. So it would just say that if this signal here coming on this line is high, or this one is high, then the output's high. So this line will normally be low, as will this one. And so as soon as this goes high, then this loop here holds that high state. I have a light here, this was for debugging purposes. Now, there are two different drivers. This one has a negative sign and that one has a positive sign. So this one is the deactivation controller, and this one is the activation controller. And they're both tied to the output there, and they're both tied to the bulb, which is set up as a toggle light. Now, so in the Visual Logic settings, the deactivate controller is set to deactivate the other object, and the activation controller is set to activate the other object. So basically what happens is that if it's a logic low, then the deactivation controller says turn the light off. If it's a logic high, then the activation controller says turn the light on. Now you can do it so that it just toggles it, but that wasn't what I wanted to do. So these are edge triggered. I was going to make one that is meant specifically for toggling that does it on both edges. But so the deactivation controller functions when it's transitioning from a high to a low, and the activation controller only activates when it's transitioning from a low to a high. So it only generates one signal and not continuously. And then the next part is the sequencer. Well, you can see here the reset switch. I just have a buffer here. It's really just a pass-through. Whatever signal's on the input is the same on the output. And it was just because I wanted to be able to not have the switch connected directly to this input here. I wanted to actually have it connected to something over there. So that's actually really the only real use for a buffer, just like this one here. I have an output here that goes to an input into a buffer because I didn't want to connect these two controllers directly to the output here because it's so far away. I just wanted to make it look clean. So this here, we have, let's see, this is the reset coming in, right? And it branches two ways. So it'll reset the state of this, I guess you can call it a memory circuit. It's almost what it is. And the output here goes over here. So if this is a logic high, see these are normally low to start with. These are XOR gates, an exclusive OR. Unlike a normal OR, the output will be low if more than one input is logic high. While with the OR gate, if any of them are high, then the output's high. Let's see, so that line there comes in, and these do their own timing. This wouldn't work in a real circuit, really. This is relying on the fact that each individual entity, like this one or this one, and this one and this one, each one is activated and processed once per frame. Like it takes like 14 frames for the signal to get here. So 15 to here. That's half a second right there. Well, if you're running at 30 frames a second. If you're running at 60, that would be a quarter of a second. So basically, what this does is it says, okay, if this one's high and that one's low, then it copies that state and then puts it on the output, and it goes to the next one and it does the same thing. So these are normally all off, so this one will turn on, and then after 1, 2, 3 frames, and then this one will turn on, and then after 1, 2, 3 frames, and this one will turn on, and all the way down the line. Now what happens is that this one here sends a signal back. This is the reset, and then so if that last one down there's on, then this one is on and this one is off. That'll make this a logic low. So then it'll turn off all the way down the line. And then when it gets back here, it says, oh, well, that line is on and this one is off, so I turn on, and it goes and keeps doing it in the loop. And then the reset, I have an inverted signal here. So whatever comes in the switch gets inverted. So if the switch is on, then this is off. And this is an AND gate. So it says that if both of these are high, then the output's high. So whatever's coming down this line, whether it's a 0 or a 1 logically, or high or low, however you want to think about it, on or off, the output is only going to go to a logic high if that switch is turned off. If it's turned on, then this will be low and we'll get nothing but zeros down this line, so the whole sequence is stopped. It's kind of complex, and now one of the things that I did add just for, this is, I would say that this is a little extreme for what most people would want to use it for. This was just a test to see if it could be done. I actually thought about making it like add 2 numbers, which would be insane. That would be a lot less work just to write a script. But for people that don't know how to write scripts, if you want to do, if switch A and switch B are both on, it makes it really simple. This is just a really complex example. But so if you notice, these inputs here that go to these controllers that trigger these lights, they're not connected to anything. And that's because one of the features that I did include is that these the inputs have the capability of receiving from a named object. So this one is named logic XOR D, and then this one will be C, B, and A. And those are here, right? So this one here is logic XOR A. So it's able to receive the data wirelessly without having to, I could have run a wire from this output over to here, and then from the next one to here, and the next one to here, and so on. But that functionality was added because just in case someone does want to use this system and maybe do something, I don't know, maybe like this, you can cram it all together in a fairly small space. I left space so that it was easier to prototype and just to show off. You probably wouldn't want to take up this much space though. But if you did, you could put it all the way on the other side of the map in a place that's completely inaccessible, and you could transmit the data using wireless receivers. So that's kind of nice there. I think that's pretty much everything about this stuff, except one thing that I do want to mention, and that's that every object, this is something that's in the documentation that I made for it, every object has this thing called is collectible. You don't ever want to accidentally activate that on any of these, because I had encountered it before, and I encountered it when I was trying to lay this out. I did put it in the actual entity, the FPE file, that value should be 0. But you can accidentally click this, or I don't know, it turns on sometimes by accident. It will trash your connections, whatever visual logic connections you have. Like say if we were to make the inputs collectible, it will destroy all of them. And even after you turn it off, that you have to go through each and every single one to click the thing is collectible to turn it off. It won't let you put the logic connections back. So you have to then delete those objects and put new ones in. So I would suggest, if you're going to play around with these, that you test and save often, just so that doesn't happen. I am making the distribution for these objects here available. The link will be in the description. And I hope everybody has fun. I mean, you don't have to use it, of course. It could be useful, though. I know some people will want to be able to play around with something like this just because it can do a lot of stuff. Anyway, if you have any questions or comments or whatever, feel free to let me know. Anyway, thanks for watching, and have a nice day.